Hey everybody, we have another fun-filled day of finding factors of a polynomial. Now, so far, the only way that I taught you to find a factor is by using a GCF. So that was yesterday, using GCF. So the good news is we're still going to do that. The good or the bad news, or whatever, we're going to take that another step further. So today we're going to learn how to find, once my pen decides to work, just joking. Maybe. Huh. Look at that, not want to work at all. Okay, how to find more factors of a polynomial. So main rule, just don't get frustrated, okay? So you remember how we used to take two binomials and put them together? And we would, do the first times the first, yada, yada, yada. And we end up with a polynomial down here. Well, today you're going to start with a polynomial and we'll end up in what we call a factored form. So let's reverse that process. Today the easier type will look something like this, not too many numbers, not too many x's, and it will become this. And then a little more difficult, we'll have a GCF, and it'll end up being this. So please realize that while there are none in the notes today, polynomials and that cannot be factored. They are called prime. So if you can only take out a 1 and there's nothing that works, it's called prime. Now, I will happily let you look at all of these steps, okay? You are going to be given a polynomial. You are going to find that polynomial's GCF, and you're going to divide that GCF out. Then you're going to identify what A is, the number of x squared, what B is, the number in front of x, and what C is, the constant in the back. Then you're going to take that A and C and you're going to multiply them and put B on this side. Then you're going to find two magic numbers that multiply to that -6 and that add to that +5. So after you find those magic numbers, you put those magic numbers correspondingly here and here. The beginning of the problem, the original 2x squared and the original -3 go here and here. Oops, sorry, I missed here and here. There you go. Then you split it off right down the middle. You can see this split line right here. I'm tracing in purple. You find your GCF of your binomial over here, in this case 2x. GCF of this one, -1. Divide out those GCFs. The insides, when you divide them out from the big purple lines, you should get the same thing. And that will give you your final factors of your GCF originally, your 1x plus 3, the parentheses that match, and the 2x minus 1 that's left. Now it's time to apply it 6 times. All right, that was a lot. Clearly that was not well explained enough for you to be able just to jump into it. So let's take a look at number 1. If you follow these steps, I promise you, you won't go wrong. Step number 1 is always identify what the GCF is. In this case, single item can be divided by a 3, not by an x, because the 30 does not have an x, just by a 3. If I divide every item by 3, that'll give me 1x squared. That'll give me 7x and 10. Step 2, you're going to identify what we call A, B, and C. A is the number in front of x squared. B is the linear coefficient, the number in front of x. C is the constant in the back. Step 3, now that you've identified A, B, and C, you're going to make yourself a little chart. And inside that chart, you're going to do A times C on the left and identify B on the right. So A times C is 1 times 10, and that came from here and here, which is just a big old 10. And B is 7, and that came from here. Next, you have to find two magic numbers that are going to multiply to 10. So they have to multiply to this 10, and they have to add to 7. Now maybe some of you are like, oh, I got it, it's 5 and 2. Well, good for you. You're probably faster than most if you were able to get it that fast. However, the process that works is this. Some kids are simply not as well versed as others in their multiplication table, and that's okay. So I make everybody learn by doing this. Count up 1 through 5. Now, if you watch the screen and you listen to my scraggly voice here, listen, please, carefully. And watch. 10 divided by 1 makes 10. If you add those, you get 11. Oop, where did my 7 go? I'm sorry. You need something that adds to 7. These factors of 10 are not your solutions, even though they multiplied to 10. Watch again. 10 divided by 2 equals 5. 2 plus 5 does make 7. We have found your magic factors. Why are those your magic factors? Because 2 times 5 will multiply to 10, and 2 plus 5 will add to 7. 2 and 5 are your magic numbers, your magic factors. Once you find them, you don't go on anymore. All right, everybody. We are going to learn how to use grouping to finish factoring this problem. So when you jump to step 4, you're going to write your original GCF of 3 first. And then you are going to rewrite this polynomial that I'm highlighting in yellow. However, you're going to leave out the 7x, and you're going to replace it with these magic numbers over here of 2 and 5x. Okay, here we go. Keep the 1x squared. Keep the plus 10. If you need to do this to show what's going on, do that. However, replace the 7x with the magic numbers that we just got. So we had a 2 and a 5, and since 7 had an x, these have an x. 2 and 5 are both positive. Now what you do is you split this in half, and you will find GCFs. Again, that 3 is kind of annoying. He just keeps coming down. Now the GCF of these items, look at my purple squiggle. What goes into 1 and 2? A 1, and they both also have an x. You will divide by 1x. Okay, I'm going to move some room down because you might visually need to see it while you're still learning. So if I divide this by 1x, I still get 1x left. If I divide this by 1 and x, all I have left is a positive 2. On this side, the GCF is always whatever this sign is, so I'm going to say positive. What goes into 5 and 10? 5. If I choose to divide both of these items by 5, I will have left an x and a 2 when you divide by 5 by 5 and 10 by 5. What's really important that you recognize now is that these match. Since these match, our final answer will be the GCF of 3. The 1x plus 2 that matched. If you need to see a visual, please follow my arrows. And what's left, I'm going to grab a blue highlighter, the 1x plus 5. It would be smart of you to redistribute that stuff together to prove that that is the answer, but for the sake of this video, I'm not going to do that right now. Step 1, we need to find a GCF. The GCF in this problem is a 2. I apologize, no it's not, because 2 does not go into 5. The GCF is a 1, and do they all have an x? No, they don't, but they do all have a single y. Please divide everything by a 1 and a y. When I divide this item by a 1 and by a y, I am left with 2x squared, and the y is gone. When I divide this by a 1 and by a y, I am left with a 5 and an x. When I divide this item by a 1 and a y, I am left with a negative 12. So everything gets divided by 1, and everything loses a y. Step next. Step 2. You will identify what A, B, and C are. A is 2. B is negative 5. And C is negative 12. Now my husband's home. Number 3. But you guys didn't want to learn, did you? You will make this fun-filled chart. You will have to put A dot C here and B here. That's 2 times negative 12, which is negative 24, and the value of B is negative 5. You will then count up and hope that it's in these 5 numbers. If not, you will need to increase. Now I will do negative 24 divided by 1 is negative 24. Add those, you get negative 25. Excuse me. I was going too fast in my head. Add those and you get negative 23. That is not the negative 5 that I needed. Negative 24 divided by 2 is negative 12. Add those and you'll get negative 10. That is not the negative 5 that I need. Negative 24 divided by 3 is negative 8. Add those. That is a negative 5, which is exactly what I need. 3 and negative 8 are my magic factors. We're now going to move on to step 4. So step 4, it's really important that you remember to bring the GCF down, which was 1y. And now remember, we are going to drop down everything that was in that parentheses. So 2x squared and the minus 12. However, and follow my highlights if you're having trouble with that. There's the minus 12, and there's the 2x squared, and there's the 1y. Okay? Now remember, I told we aren't going to drop down minus 5x. We're going to drop down the magic numbers that we got. So what did we get? We got a 3 with a negative 8. That replaces our negative 5. And since negative 5 had an x, these each have an x as well. 3 was positive, 8 was negative. Now, just like we did in the problem before, we split it in half. Again, carry down that pesky GCF of 1y. Now what you need to do is be able to look inside of this right here. See my squiggle? What goes into 2 and 3? Hopefully you're thinking 1. What goes into x squared and x? Hopefully you're thinking x. That's why we studied GCFs in the lesson prior. If you divide by 1 and x on each of these, 2 divided by 1 is 2, x squared, take away an x is x. Plus, 3 divided by 1 is 3, x divided by x is none. I told you in the last problem, you always take this sign down, so we are going to be dividing by a negative. Please, what goes into 8 and 12? I do hope that you think 4, not 2. You want the GCF. Do they both have an x? No, they do not. So we're going to divide both of these terms by a negative 4. I write our result there. Negative 8 divided by negative 4 is positive 2, and it has an x. Negative 12 divided by negative 4 is positive 3. It does not have an x. It's important now that you notice that these parentheses match. Okay, what we will do now is carry down our GCF of 1y. We will carry down our matching parenthesis, which was this 2x plus 3. It's like another form of a GCF. And then we'll carry down the leftovers of what we haven't touched yet. If you're not sure what that is, it's this 1x and this minus 4. And it will go here. I'll highlight that in case you're like to see those colors. That is the fully factored answer. Again, if you wanted to distribute it all back together to prove that that is the answer, you can. Step 1. Let's see, what color is step 1? Green. My husband's here. Maybe he'll want to come factor with us.
Did you say factor?
I did. The GCF is the number and the variable that's common to all of them. In this case, everything divides by 2. Everything also has a single x at least. Divide this by 2 and take away an x. You'll be left with 6x squared. Divide this by 2 and take away an x. You'll be left with 1 and x. Divide this by 2 and take away x. You'll be left with a single 1. Step 2 is blue. Ooh, step 2 is blue. That rhymes. Identify A as 6, B as 1, and C as -1. Step 3. Make a chart. On the left, you have to put A times C, and on the right, you have to put B. A times C is 6 times -1, which is -6, and B is 1. So that came from there, there, and there. If you don't know two numbers that multiply to -6 that add to 1 right away, you need to go through that process. So I would do 1, 2, 3, 4, 5, and hope that it's in there. -6 divided by 1 is -6. Add those together and you get -5, which is not what you want. -6 divided by 2 is -3. Add those together and you get -1. That is also not what you want. However, there is a rule that if you get the number you want, for example, I wanted a 1, but you get the wrong sign, there's a cute little trick where you just change, and change all 3 of those signs, and that'll work. If you really want to test it out, which I'm sure you do, -2 times 3 is -6. And if you add them, you get the +1 you want. Your magic factors are -2 and +3. Ready for step 4. So step 4, what we need to do is we will carry down the GCF from the original problem. We will carry down the entire parenthesis, which was 6x squared, and that -1 in the back. Please follow my highlights. There's the -1. There's the 6x squared. There's the GCF. The next thing we do is, yes, we do technically carry down this +1x, but we carry it down using those magic numbers we got, which in this case was a -2 and a +3. So -2, +3, and since the 1 had an x, these need to have an x since it's replacing it. The next thing we need to do is to split this thing in half. Boom, right there. Bring down that pesky GCF of 2x. Now, what goes into 6x squared and -2x? Hopefully you're thinking the GCF is 2 and x. So each of these will be divided by 2 and by x. And here's where that's coming into play. If you divide 6 by 2, you get 3. X squared by x gives you x. So this kind of flows right here. What is -2 divided by 2? -1, and the x's are gone. Remember I told you in the previous problems, you always divide by that sign. Now what goes into 3 and 1? Not 3, just a 1. Do they both have an x? No, they do not. So you're going to be dividing by +1. 3x divided by +1 is still 3x. -1 divided by +1 is still -1. What you need to notice now is you know we did it right. If these match, we did a great job. So let's talk about final answer. The GCF, that pesky 2x, is going to plop down. The matching parenthesis of 3x minus 1 is also a form of a GCF. That's why it plops down. And then the leftovers, the 2x and the positive 1, that pops down here as its new binomial. If you wanted to take the time to distribute those together, you would notice that those do make what we had originally. Every time I'm trying to speed it up a little. Step 1, find the GCF. The GCF in this particular one is, well, what do they all have in common? I see that they all have a q, at least a q to the first power, and they all also have an r to the first power. So I got to take a q away and an r away, a q away and an r away, a q away and an r away. Please note that they don't all have a coefficient that's common to take out, so it's just variables as your GCF. You're more than welcome to chime in if you want. You don't have to. If you take out a q and r of this, you will get a q to the second power, and the r's will go away. If you take a q out of this, you'll be left with a q to the first, and these r's will go away. If you take out a q, these ones go all the way away, as do the r's. So we've taken out the GCF. Step 2. Find A, B, and C. A is the coefficient of the first. B is the coefficient of the linear, like the power of 1. And C is the constant in the back. Step 3. Step 3 is where you make that chart. You put AC here and you put B here. AC is 1 times 24 and B is negative 10. So we have to get two numbers that multiply to 24 and add to negative 10. If you know them right away, good for you. Most students do not. 24 divided by 1 is 24. Adding those together, you get 25, which is definitely not the negative 10 that we need. 24 divided by 2 is positive 12. Adding together is 14, which again is not the negative 10 that we need. 24 divided by 3 is 8. Adding together is 11, which again is not the negative 10 that we need. 24 divided by 4 is 6. Adding together is 10, which is close to our negative 10. Remember I told you in a previous problem that if you get the right number, 10, but the wrong sign, you change. Negative 4 and negative 6 are what we call our magic factors. Step 4. We are now ready for step 4. This is the grouping step. You bring down that pesky GCF, which was Q1, R1. For simplicity's sakes, I'm not going to bring down the ones. They're implied. And then we do bring down the big parenthesis. We have our 1Q squared, and we have our positive 24. Follow my yellow highlights if you're having trouble figuring out where those came from. Now, again, we will bring down this minus 10Q, but we'll bring it down in two separate terms. And we're going to use these magic numbers over here. So instead of bringing down negative 10Q, we bring down minus 4Q and minus 6Q. They already have signs. If they didn't, we'd use a plus. Now what we do is we split that in half. Pause the video if I'm going too fast, okay? That pesky GCF of Q and R just plops down. Now what's the GCF of 1Q squared and 4Q? Hopefully you're able to answer that it is a 1 and a Q. That came from the previous lesson, just finding your GCFs. Divide by 1 and take away a Q on each term. 1 divided by 1 is 1. Q squared, take away Q is Q. Negative 4 divided by 1 is negative 4, and the q's are just totally gone. They cancel. In the second parenthesis, remember I told you always bring this sign down. Can you figure out what goes into 6 and 24? The answer is a 6, a GCF. You might say 2, you might say 3. You need a GCF, so we need to say 6. So we're going to divide, and no q's. We're going to divide each term by a negative 6. Put our parentheses so we can write our leftovers. Negative 6 divided by negative 6 is 1, and a q is still left over. 24 divided by negative 6 is minus 4. What you need to notice is that these parentheses match. If the parentheses match, you can probably assume you did something wrong. Now, the only time that wouldn't be the case is if it's a prime. So you need to be super duper duper careful. 9 times out of 10, they're going to match. And if they don't match, 9 times out of 10, you did something wrong. If they don't match and you're not sure if you did anything wrong, just come and ask. We are ready for our final answer. So that thing from the very beginning, our pesky GCF of QR comes down. Our matching parenthesis of 1q minus 4 is like a new GCF, so we put it there. And then we put the leftovers. I'm going to highlight the leftovers in blue. Is 1q take away 6. That's your final answer. The only thing I'm going to do is tell you the keystones are not going to have the ones in front of the variables because that's something we should know. Okay, GCF. What number, not a trick, maybe just hard. What number goes into 48 and 27?
Ooh, my.
Well, think about 27. What goes into 27?
9 and 3.
9, 3, and 1.
Mm-hmm.
So what also goes into 48?
Well,
Not 27.
No.
And not 9.
3.
So it's a 3. Do they both have an M or an N?
They have an N.
Then that would be our GCF. So we're going to divide by 3 and take away an N. Divide by 3, take away an N. Okay. Divide by 3, what do we get?
I'm going to go with 16.
Take away an N, what do we have left?
M squared.
Divide by 3, what do we have left?
Be a 9er.
And what do we know about those N's?
Gone.
Good. And it's like n to the 0 power, which we don't write. I don't like how smushed that is. Step next, 2. A is the number in front of the squared term.
Okay.
Which
so
is?
16.
Careful. B is the number in front of the M to the first.
I'm gonna, wait, hold on. 1.
0.
There's not
we
the
have
first.
No M to the first, so B is 0.
Okay. 0 times, I think, 0. Yeah.
C is the number in the back.
Negative 9.
The constant without a variable. Okay, now for our chart. The chart puts AC here and B here. AC is what?
16 times negative 9.
Oh dear.
Oh, that's a big number.
144, right? Negative 144.
Yeah, I think so.
And B is?
0.
Okay. I'm just going to save time. I'm going to tell you.
Oh, I know it.
Oh my gosh, hold on. But you have to understand not everybody has the brain that you have.
Well, I just got really excited for a second.
Well, that's good. It's very hard for kids to make it through this one.
Well,
Now, if you divide, if you divide by 1, let's just do a couple to prove that it's not those. If you divide by 1, you get negative 144, and if you add, you get negative 143, which is certainly not 0.
No, not 0.
If you divide by 2, you get negative 72, which if you add is negative 70, which is certainly not 0.
Nope.
If you divide by 3, don't you get a decimal? No, you get 48. Okay, so if you divide by 3, you get negative 48, and if you add, you get negative 45, but who cares because it's not 0. If you divide by 4, it doesn't work. If you divide by 5, there's your decimal. Let me get this. So I'm going to do negative 144 divided by 5, decimal. Negative 144 divided by 6, 24. So if you add those, what do you get? So this one's no good. I know it's not 4. What do you add? Add those to be negative 18. That's not it. Negative 144 divided by 7. Negative 144 divided by 8. Okay, so maybe, so no, because you can't get a decimal. So negative 18, negative 10, getting closer. Negative 144 divided by 9 is negative 16, which is negative 7, but not it. Negative 144 divided by 10, decimal. Negative 144 divided by 11, decimal. Negative 144 divided by 12, negative 12. And what do you get if you add those?
0.
Was that going to be your guess originally?
It was.
My hero.
The only reason I just knew 12 times 12 was 144.
Now ready to move on to step 4. So step 4, remember this pesky GCF? It comes down. And then we do have the 16M2. We do leave the space and put minus 9. Our magic numbers of 12 and negative 12 go here and here. And it's always half of this exponent. So in this case, it would just be m to the first power. And this 12 is positive. We cut our problem in half. The GCF of 3n comes down. What is the GCF of these two items? What goes into 16 and 12? The answer is a 4. And they each have an m. So we're going to divide by 4 and m each time. 16 divided by 4 is 4. M squared, take away an m is an m. 12 divided by 4 is a 3, and the m's cancel. I tried to teach you that this sign is always what you'll divide by. Do you know what goes into 12 and 9? Hopefully you know that 3 is the GCF between 12 and 9, so we need to divide by a negative 3. The result will go in parentheses. Negative 12 divided by negative 3 is positive 4, and there is an m left. Negative 9 divided by negative 3 is a positive 3, and there's no m's. It's important that you see that these parentheses match right here, the squiggles. Please look at the squiggles. Since that's the case, we drop down our GCF from the beginning. We drop down the matching GCF parentheses of 4m plus 3. And interestingly enough, look at what we have left. We have a 4m minus 3 that's left. That's our final answer. You could distribute that all together to prove that that is correct. GCF.
This is better than Mario Kart.
I highly disagree. GCF. I told them today, though, that math was like a video game. The more you practice it, the better you get.
That's a very true statement.
I think so. I mean, so it's really just like playing games all day in
Yeah.
my room. All right. What goes into 16? Whoa, this is... Okay. What goes in to all of those coefficients?
Ooh, 2?
Mm-hmm. So let's take that 2 out. Divide this by... And they don't all have an x. So what is that going to be?
8x cubed
And then this one.
minus 12x squared
And then that one.
plus 2x minus 3.
Okay. Now something special to note about this one. Special. Do you notice that this has 4 terms? Can you notice that that has 4 terms?
I see that, yeah.
Okay. They should be really happy when that happens. So we have this special 4 terms, and really it should make you pretty happy because when you have 4 terms, you get to skip steps 2 and 3. There are no magic numbers to find. So you pull down this GCF just like we have done. I wish I hadn't written right there, but we are going to split these in half automatically. It's split in half like now. I'm going to change the pen to a little bit thicker so I can write over my cute little special 4 terms. So the 2 drops down. Do you know what goes into 8 and 12? Hopefully you are thinking a 4. And the GCF between x squared and x3 is x squared. So we are going to have to divide out a 4x squared out of both of these terms because it's the GCF. 8 divided by 4 is 2. x3 take away x2 is just x. Negative 12 divided by 4 is negative 3, and the x squareds cancel. You will divide out a positive on this side. Do you know what goes into 2 and 3? Hopefully you're thinking a positive 1. Guess I can extend that. Divide both of these by a positive 1. When you do, you get 2x, take away 3. Dividing by positive 3 is kind of nice. It just gives you the same thing. And then these 2 matching things come down after the GCF. So 2x minus 3 is your new GCF that comes out by your 2, and the leftovers come behind it. Now that's in fully factored form. You can see, since we didn't have to do that whole chart business like we did over yonder, it really was a lot faster.